Hello everyone, my name is Yann Leflour and I'm Deputy CTO at BAM, which is a French mobile app development agency. You can find me on social networks with the handle Leflour on LinkedIn, GitHub, Twitter, and I also write on my personal blog joy2.dev. And today I wanted to talk to you about navigation in React Native. Before we go into technicalities, I wanted to talk to you about the history of navigation itself and the mental model we have associated it with. To understand the way we have come through architecture navigation in applications, we have to talk about the way we locate information in the real world. Let's take a library, for example. In order to find the information you're looking for, you have to first locate the proper shelf in which the books about the subject you are searching for are located. Once the shelf is located, you have to find your book. And when you find your book, if you're looking for specific information, you also need to search within the book itself for the page you are looking for. As you can see, the way we order information in the physical world is done according to a tree structure, where each level allows us to fine-tune our search. So now let's go on to the digital world. So what happened is that in 1965, while they were working on Multext, one of the early operating systems, P.G. Newman and R.C. Daly published a paper describing what is still known today as the modern file system. As you know, it took inspiration from the physical world by applying the same tree structure that we have seen to information storage. In parallel, we had Ted Nelson, who, while working on Project Xanadu, which was to be the first internet, coined the term link and its usage to navigate between entries. So, when the first web browser was released in 1990 by Tim Berners-Lee, it ended up relying on the same file system structure and used hyperlinks to navigate between them. It also stored the page's history through a navigation stack. So to sum that up, we've got the browser, which displays a page. When we click a link on a page, it changes our navigation stack by asking the server for another page. Now, server side, the router on the server locates the page according to a directory tree and sends it back for display. But even though this model was efficient for reading, the need quickly arose for persistent interactions with the websites themselves. We needed navigation basically to go from stateless to stateful. And according to my opinion, I think three main concepts played a key part in this transition over the years. The first one was the definition of the MVC pattern in 1988. The second one was the proposal of the query string standard starting in 1995. And the last one was the proposal of the cookies standard starting in 1997. And here is how they impacted navigation. Considering those principles, here's what happened if we take into account modern MVC framework. Links were given parameters with the query strings. The server became responsible for storing a user session and persist data thanks to the cookies. Also, with modern server-side frameworks, pages became templates. Now, in order to allow reusing some parts of our code. The next major step in the evolution of navigation came with the rise of the single-page application. While it was conceptualized in 2003 this architecture only really took off with the rise of the AngularJS framework, which was released in 2010. The concept of SPAs provoked a real shift in the way we now architecture navigation. Because there now was a single file, which meant a single path, navigation through the browser stack couldn't work anymore. To solve this issue, SPAs gave a greater role to the JavaScript engine by implementing its own client-side routing. Templates became components, also moving to the client side. They provided the output of what had to be displayed. And the JS router was now unable to use the browser's navigation stack, so one was re-implemented in JavaScript. And well, I know there was an update in the browser's history API, which reversed this trend, but we'll keep it that way for comparative purposes. Finally, the concept of session was also moved to the front end under the guise of what we've come to know as the store. That left the server to be only used for stateless data calls, and that is if you follow the REST protocol strictly. Now, code-wise, if we look at navigation handling with Angular, we can see the remnants of past patterns. First, the navigation is declared as a tree to remain consistent with the URL pattern, and navigating is considered an imperative action from the user. And when we look at React Router for React.js, the exact same can be said. So when switching to React Native, as it emerged from React.js, making it appealing for web developers, is it really surprising that it retained the same navigation principles? But while navigation has proven itself through time, it also came with its own issues, which is why we have to talk a bit about imperative versus declarative. See, alongside React was released the concept of the Flux architecture. It aims at a unidirectional data flow. To illustrate it, I won't go into too many details. A state is given to a component by our store to display its data. And the component can send an action to our store to receive an updated state. But if you remember, we have grown accustomed to navigation being handled by the browser, with our stack handled by a navigation library. And if you isolate its essence, it turns out that in accord to the Flux architecture, our display is handled by our components. Navigating itself is actually an action sent to our stack, and the stack is actually also a navigation store, resulting in a navigation state. So now we have our entire navigation on a store we don't fully control because it's handled by an external library. And according to my own opinion, it causes a couple of issues. The first issue is having a page name as a parameter, because we're so used to routing with URLs. It is essentially the same as calling a show method directly on our destination page instance. And I think this is a well-hidden imperative call and an anti-pattern to the Flux architecture. And it also breaks the principle of separation of concern, as a page has to know what its next page is. For example, if we navigate to a profile page after login, our login page itself becomes interconnected with the profile page logic-wise. And if you decide on creating a navigation service to leave your component outside of this business logic, it only worsens things by making navigation a side effect of your store actions. And this service becomes a default when you start listening to events provided by your phone. Now, my second issue with navigation is that it's everywhere in your code, basically. Here is an example of a simple app that I built consisting of only 2 pages. The first page is logging in with Dropbox, and then once you've logged in, you select a folder. Here is a high-level diagram of the app without navigation. I find it simple enough, and you can clearly see the Flux architecture. Now look at what happens when we add navigation. It becomes interconnected with every part of our app. But I have one last gripe with navigation, and it's the fact that I think you don't actually need it. See, if we come back to the initial definition of navigation, it's the action of going from one page to another page based on a user action. But if you take our app navigation architecture, we don't have pages anymore, and we don't have a browser requiring a URL or handling our navigation stack. So the concept of navigation itself, as we understand it, is only a mental model linked to our past as web developers. And React Native itself has shown us that with its own components that we can write navigation in other ways. Let's take an example. We have the model, which is one of the core components of React Native, and it uses a purely declarative way of handling itself and its transitions. So my question is, why can't our pages do the same? Also, removing navigation is not only a developer concern, but has also become a designer one, as we'll see with the concept of NoNav. The term NoNav was coined by Caroline Bénard, one of my colleagues who's head of design at BAM. About a year ago, she came up with the concept of NoNav, which she wrote about in an article, I think it was in early January. It states that navigation should be your concern number 2 after the concept of your product, because a bad navigation is a brake for adoption and decreases the product perceived value. With mobiles, we have less space to display the same level of information, which of course led to requiring more navigation to reach the desired feature. Yet because of mobility and the reduction in attention spans, our users actually want the opposite and need faster access to features. So, is it not surprising that most redesigns initiatives aim to reduce navigation? Let's take a look at the redesign of Messenger. It went from 2 tab bars with a whopping total of 8 tabs to a single one with only 3 tabs. And if you take Uber, basically they mapped their user journey. So you search for a vehicle, you wait for it, you have the ride, and then you rate your ride. By using this user journey, they managed to produce not 1, but 4 distinct home pages in order to avoid any navigation at all. And the beauty in this concept, I think, is that in the user's perspective, if you use the context to show them what they need, when they need it, to them it feels like magic. And doing this has even been simplified thanks to the information given out by the mobile itself. We have access to tools such as position, Bluetooth, network status, push notifications, deep linking, sharing, and many more. and all of them give us even more context, often outside of any user's interactions, and allow us to deduce the user state without navigating. So, what can we do as developers to achieve NoNav in React Native? Well, thanks to another of my colleagues, we have a solution. Thomas Pucci, a VP of Engineering at BAM, published a library called React NoNav, which handles navigation in a purely declarative way. What it does is only handle transitions using two main components: a canal to handle transitions between children, and a screen to declare a component's own display state. If you go into its configuration, it's the transition itself. And where I believe this library shines is that because it only handles transitions, that allows us to take back control of navigation through a single source of truth that we can manage ourselves. But we're not done yet. See, we took back control, but because the current state is in our own store, we now have to compute a new state upon receiving a navigation action. For example, if we receive a login event and our previous page was the home page, then we simply, in our new state, go back to the home page. But if our previous page was the order page, then the current page should become the confirm page. And let's say we want to compute if the confirm page should be displayed. Well, we might have to take into account other state values. For example, if our network is down, we might not want to redirect the user to a confirmation page. The way we translate it into code is by nesting if conditions, which will become messy and bug-prone whenever we're scaling or writing down complex user journeys. So this is where XState comes into play. XState is a fully featured state machine library for JavaScript, which was created by David Khorshid, and which adheres to the W3C state chart specs. Here is a simplified explanation of the core blocks of a state machine. Well, you have the main blocks are the states representing our system at a specific point in time. When receiving events, we transition between states. We also have a context to share data between states. And services, which are side processes controlled by the machine that can send events to it. Finally, there are actions, which are side effects. They come under many forms and we won't go through all of them. But our main one are assign actions, which allows us to update our state, and classic actions where we don't listen for any return event or value. The core difference with traditional state containers such as Redux is that those libraries only offer a subset of XState's tools. If we take Redux, for example, the context is equivalent to the store, our action to the reducer, and the event to actions. So the entirety of Redux can be summed up by only 3 of the tools available in XState. And the extra layer of tools allows us to streamline our developer experience greatly. Services are a native way of handling all of our phone's context, as they translate callbacks into events. And fire and forget actions are very useful to handle things such as logging or analytics. Finally, states, events, and transitions allow us to map our business logic without having to rely on nested ifs conditions. Here is how you declare a machine. You give your machine an ID, an initial state, and context. You declare your available states, the events which can be handled by each state, and the transition which can be selected according to a condition. You can also start services to listen to external events. and trigger side actions in reaction to an event. And all of that can be previewed with a useful online state machine visualizer, which resembles much more what we would draw on a board than a long list of conditions. And if you remember the Dropbox app, because state machine allow nesting and parallelization, I was able to split my navigation architecture. And this allowed me to isolate completely what we considered as pages into their own black box isolated modules, which meant that I could essentially reuse my pick folder or logging page anywhere in any other app. So, to sum everything up, we have mobile navigation, which is a mental model that came from our past. Our mobile users want to avoid it. To do that, we need to use as much context as we can, but context gets messy because of imperative navigation. And we also need to control it ourselves, which means that it is complex to write down because of nested if condition. So what we do is that we use React NoNav to handle transitions based on declarative props, and we use XState to handle our context and map complex user journeys. And this is why I really welcome you to try out taking back control of your own navigation with XState and NoNav. Thank you so much for listening. If you want to find out more, you can head out to joy2.dev/xstateNoNav, where you'll find the slides with my notes, links and references, and of course an open source example of an app using XState and NoNav that you can play with and deploy. Thanks again for tuning in, and I would be delighted to talk to you on social platforms to discuss this talk. Bye!